Hello dear students. Right. So previously we completed gaseous state. So the various concepts of gaseous state have been discussed. Right. Molecular velocities like RMS velocity, then most probable velocity, average velocity, then kinetic molecular theory of gases, right? Then Viril theorem and reduced equation of state, collision frequency, and all those things we have covered in that previous class. So somewhere we can utilize those equations also, right? Now coming to the part of solutions, right? So new chapter, solutions. What is meant by solution, right? So whether that may be applicable to physical state, various physical states are there, solids are there, liquids are there, and gases are there. With the help of that, how many kind of solutions we may prepare, and what was the syllabus mentioned in our examination. So before that we will go through the detailed classification of solutions, all those things, right? So what is meant by solution? Solution is a homogeneous mixture. It is a homogeneous mixture of two liquids. Homogeneous mixture of two liquids, right? So or two or more than two liquids also will be possible. So generally for homogeneous mixture of two liquids means such solution we may call as binary solution. This is applicable for binary solution because only two liquids are mentioned. If many number of liquids will be there, so that is called the corresponding solutions, like 3 will be there, ternary, 4 will be there, quaternary, like that, right? So the complete homogeneous mixture of two liquids that forms a binary solution. A binary solution, right? So means what about those, right? So if it may consider a solution, so that will be mixing of two liquids. So that is, one will be solvent, the other will be called as solute. So by mixing of this solvent and solute, that can form solution, right? So that can form solution. The homogeneous mixture of solvent and solute, that can form solution, right? So what is meant by solvent, what is meant by solute? So that will be respect to the solution, right? So in solution, the major component that will be present in the solution, right? In solution, major component is considered as or treated as solvent. Major component is treated as solvent, and minor component which is present in the solution, that is called as solute. The minor component that will be present in the solution, that is called solute, right? Solute is always what? Minor component. So the solute is always minor component, right? And also here, right, so how many components, how many liquids are there? Two liquids are there, therefore that becomes what? Binary solution. In that binary solution, the homogeneous mixture of solvent and solute, that forms solution. In this, major component is the solvent and minor component is the solute, right? So the major component is the solvent, that is always one component only. That is always or maybe one component, right? So the solute may be one or more than one components, right? So that means maybe one or more components. The solute means a small portion. So there are many number of components which will be present in the solution. So that is called, whenever small portion, many number of components are there, that becomes treated as what? Solute. But solvent is only one component. So that is the solvent, right? So means out of all, for example, a solution is made with so various number of components. What is the maximum component? Means major component which will be present in the solution, that is called solvent. The remaining all will be treated as what? Solutes, right? So the remaining will be treated as solutes. This is the solvent plus solute, that becomes solution, right? So in this solution, right, in this homogeneous mixture, right, so the throughout the mixture, right? So the distribution of solvent and solute particles into the solution in throughout that mixture, so that will be same only, right? So therefore, so this is the homogeneous mixture of two solutions, right? So whenever solution is consisting only two liquids, that we may call as what? Binary solution. That we may call as binary solution, right? So if solution is consisting three liquids, that we may call as ternary solution. If solution will be consisting four liquids, that becomes what? Quaternary solution. Quaternary solution, right? As we mentioned, this is, so all are belongs to what? Homogeneous mixture, right? So sometimes there is a possibility of heterogeneous mixture also will be there, means so small portion of solid is converted to the added to the liquid, so that becomes form heterogeneous, right? So the example for this homogeneous mixtures means, right, so water is mixed with HCl, so that forms a homogeneous mixture. So water will be major component, therefore that is acts as solvent. So the HCl will be minor component, so that will be acts as solute. Some small amount of solute is added to the large amount of water that can make HCl solution, so that solution will be homogeneous mixture solution, that is called binary solution. And in this two component systems will be there, one is the solvent and other is the solute. So like that, if one more will be added, so little bit alcohol will be added to that. So two components are there like HCl and alcohol, that is overall three components are there, that is known as ternary solution. If four components will be there, that is quaternary solution, right? So this is about solutions, right? So solution is nothing but homogeneous mixture of two liquids, right, or more than two liquids that can make a solution, right? That can make a solution, right? Then coming to the part of types of solutions, right? So as we discussed that homogeneous and heterogeneous both will be there, right? So the solutions, types of solutions, right? So that means the first one will be homogeneous solution, that is, right? Next one will be heterogeneous solution. Heterogeneous solution. Homo is nothing but only one phase is present, so there are two different kind of phases will be there, that is called heterogeneous, right? So in this homogeneous mixture, right, homogeneous mixture means, right, only one component or one phase is present. Either that may be solid phase, liquid phase or gaseous phase, right? Only one phase is present, that is called homogeneous solution, right? So there are more than one phase is present. More than one phase is present, right? So more than one phase is present, that is called what? Heterogeneous solutions, right? So in homogeneous mixture, right, in homogeneous mixture, the composition and properties are uniformly distributed throughout the solution. Uniformly distributed throughout the solution, right? Composition will be, means whatever is the composition of solvent and solute will be there in homogeneous solution, that composition will be distributed uniformly throughout the solution, and properties also will be distributed throughout the solution. But in case of heterogeneous, right, the composition and properties do not uniformly distributed, right? Not uniformly distributed throughout the solution. not uniformly distributed throughout the solution, right? Composition and properties, right? If you may consider the example of homogeneous solutions, right? Simple NaCl will be added to water, NaCl solution, right? Or else sugar solution, some amount of sugar will be added to water, so that can make sugar solution or NaCl solution that becomes homogeneous, consisting only one phase, that is the liquid phase only, right? So here the example of heterogeneous solutions, what? Sand solution. Sand solution means, so add some sand particles to the water, right? Water is a solvent, add some sand particles, so that can make sand solution. In that, two different phases will be there, so therefore more than one phase will be present in that solution. Such solutions are called heterogeneous solutions. Only one phase will be there, that is called homogeneous solutions. So the homogeneous mixture of two or more components, so can make composition that will be distributed uniformly throughout the solution, that is called homogeneous. There is no uniform distribution will be there. So like simple, take water and add sand particle will be settled down only. So that sand may not be distributed in throughout that liquid. So that is not uniformly distributed into throughout the solution. So this is about homogeneous solutions and heterogeneous solutions, right? So one is the homogeneous and other one will be heterogeneous. And based on the solvent nature also, there are various kind of solutions will be there, right? That is based on nature of solvent, right? So the classification, so we are going to check. So that is based on, right, one second. Right, based on solvent, or solvent nature, based on solvent nature. So there are various kind of solutions will be there, right? So whatever is the solvent, we'll see. Solvent is a major component which will be present in the system or solution. Major component which will be present in the solution. If the solvent will be water, right? Solvent will be water. So such solutions are called as what? Aqueous solutions. Where the water will be solvent, such solutions are called aqueous solutions, right? So water, whatever is the substance is dissolved in water, that becomes aqueous solution, right? So instead of water, if we may, right? Instead of water, if you may use other substances, that is like CCl4, right? C6H6, CHCl3, these all are non-polar solvents. Therefore CCl4, carbon tetrachloride, this is the benzene, this is the chloroform. So such solvents are such components are acts as the solvent in the solution, means major components are these. Such solutions are called as what? Non-aqueous solutions. Non-aqueous solutions, right? If one more will be there, right? So that is third one. So if alcohol will be acts as the solvent, means major component is the alcohol, right? So the major component is the alcohol, means such solutions are what? Alcoholic solutions. Such solutions are called as alcoholic solutions. Next, fourth one. Ether is a major product, means a major component. If you may consider any solution, that solution consisting major part is ether. Therefore such solutions are what? Ethereal solutions. Right? So if the major component will be liquid ammonia means, so that is such solutions we may call as ammonical solutions. This is purely based on solvent nature only. Whether solvent is water, aqueous solutions, solvent is non-polar, right, that becomes non-aqueous solutions. Solvent is alcohol, alcoholic solutions. Solvent is ether, ethereal solutions. Solvent is liquid ammonia, ammonical solutions, right. So just one more will be there. So if one of the component is mercury, right, that may be, this may be either acts as solvent or solute, whatever it, that is particularly in case of mercury, right. So the obtained solutions are called what? Amalgam solutions. Amalgam solutions, right. So for example of amalgam solution, sodium is combined with mercury, so that becomes sodium amalgam, or zinc will be combined with mercury, that is zinc amalgam solution, right. So one of the component is the mercury, so that mercury is containing solutions are what we may call as amalgams. This is the based on the solvent nature, particularly what kind of solvent we are using, major component, what is the nature of that major component, based on that we will get the various kind of the solutions, right. So then with respect to this, right, we may go through the classification of solutions, right. So there is a huge classification will be there. From that so we can get so one kind of main kind of classification, and we are going to discuss about the various properties regarding that, right. Next one, classification. This classification will be based on physical state. Based on physical states, that may be either solid, solvent or solute, right. Based on the physical states of solvent and solute. Physical states of solvent is what? Major component. Solute is what? Minor component. In any situation, major component is the solvent, minor component is the solute, right. So based on that, so we can get, right, type of solutions. So there are various kinds will be there, types of solutions, that is the main category. In that, physical state of solute, physical state of solute, right. Next, physical state of solvent, right. Next, examples. Based on this, so first, how many type of solutions we have, right. So we have idea about those three kind of solutions will be there, right. So with the help of the three kind of solutions, right, these are the three kind of major types of solutions in which so the physical state will be quite different. So the first one will be solid solution. The first one will be solid solution. Whatever is the solution becomes solid solution means the major component will be what? Solid only, right. So therefore that is the solid, solid and solid. So when major component is solid, the minor components that will be belongs to solute, right. So that will be once solid is there and liquid possibility is there and gas possibility is there. Means major component is solid, minor component also solid. By mixing of both solid and solid, solid combinations will be what? So we make alloys. Alloys means that is combination of metals, right. So we are making ornaments with the help of copper will be added with Rm, right, or else copper is added with zinc, copper plus zinc, right, copper plus tin, right, copper plus nickel, right, all those things, these all are what? Alloys, right. So when liquid is present in the solid, right, a small amount of liquid, this will be present in solid, right. Solid will be major component, so therefore the small amount of liquid will be combined with solid. So just now we discussed that amalgams will be there, right. Mercury will be small amount, that is the liquid, mercury in the form of liquid, so therefore mercury with sodium form amalgam, right. So that is, liquid is the mercury, small portion of mercury which is combined with sodium metal that can form sodium amalgam, right? What is the amalgam? That is sodium amalgam, NaHg, right? When gas is in solid means, so various times we may use hydrogen gas in platinum or palladium surface, right? Hydrogen gas and present in platinum and palladium. So we make the solution of gas with the solids, that becomes, we will give hydrogen gas in platinum. Second kind of solutions will be liquid solutions. Liquid solutions. These liquid solutions will be consisting, major component is what? Liquid only, right? So just I am going to write first major component, that is liquid. Major component is always liquid. Such solutions are called liquid solutions. The minor may be, that becomes a solid, right? That becomes liquid, that becomes gas, right? If small amount of solid is dissolved in liquid, so that is NaCl solution. Sodium chloride salt will be dissolved in water, right? So that is the NaCl solution, right? Or sugar solution. A small amount of sugar will be added to water. Water is a liquid, that is a physical state of solvent will be liquid. The physical state of solute will be solid, NaCl or sugar solution. Now both are liquids, right? Both are liquids means the solution of, right, H2O plus C2H5OH, alcohol plus water. Alcohol is the liquid and water is the liquid. The combination of alcohol and water, that becomes make liquid solutions. Then gas in liquid. Gas in liquid means what? So carbon dioxide gas which will be dissolved in water, right? CO2 in water, right? Carbon dioxide is dissolved in water, or oxygen gas is dissolved in water. That is the example for gas in liquid, right? So coming to the part of third category, so that are what? Gaseous solutions. Gaseous solutions. In gaseous solutions, what about the major component? The major component will be gas only, right? The major component will be gas. So same kind of terminology we will utilize in even colloids also, right? But here in place of this physical state of solute and solvent, we may use what? Dispersion medium and dispersion phase. With respect to the dispersion phase and dispersion medium, we can get various kind of the components like sols, aerosols, gels, aerogels, right? Emulsions, all kind of colloids we will get. So at the time of colloids we are able to discuss all those things. So such kind of solutions we will get, except gas and gas, right? That is in colloids, sorry, that is in colloids, right? Here the minor component is what? So again we have to take solid, then liquid, so then gases, right? Solid in gas, the major component is the gas only. So therefore the examples will be, right? So camphor is the solid, therefore camphor is present in nitrogen gas. So a small amount of camphor which will be dissolved or present in nitrogen gas, right? Liquid in gas. Liquid in gas means what? So liquid is a chloroform. So this chloroform is present in nitrogen gas, right? So when gas and gas will be there, atmosphere will be there, that will be consisting gaseous mixtures or mixture of gas. Mixture of gases that will be present in air. This is the example, right? So these all are, right, examples for the corresponding solutions, right? So there are 9 kind of solutions will be there, but the majorly type of solutions will be solid solution, liquid solution and gaseous solution. So but in our syllabus they mentioned, right, so type of solutions will be what? Liquid solutions. We are going to discuss about liquid solutions only, right? So means what is the solubility of solid in liquid, what is the solubility of gas in liquid, then what about the concept which will be related to liquid and liquid, that will be mentioned in our syllabus. So right, these solid solutions and gaseous solutions, just for example point of view, so we will discuss. we are going to discuss about right. So directly what is the syllabus mentioned in the solutions means, so directly that are solubility heading will be there. So but we have to know the solubility concept. Before that some basic concepts will be there. Definitely we have to know all those things. With the help of that we have to discuss about the solubility, and that is particularly about what? Liquid solutions. This entire syllabus will be mentioned, right? All these three we are going to discuss, that is solid in liquid, then liquid in liquid, and gas in liquid. All these three topics elaborately we have to discuss. That is our main syllabus, right? In addition to this classification, some other kind of types of solutions will be there, right? So particularly what? Liquid and liquid only, right? So liquid solutions are different kind of solutions will be there. After that we have to discuss about the what? Solid in liquid and gas in liquid. What is the solubility, that we are going to discuss, right? So then coming to the part of one more types of solutions are liquid solutions, right? So just put heading liquid solutions. This is very important, means what kind of solutions we have in our syllabus, that is liquid solutions. Right. Liquid solutions means what? Liquid in liquid. Particularly liquid in liquid. This liquid will be what? Solute. So this liquid will be what? Solvent. Then combination of liquid in liquid, that becomes forms liquid solutions. The combination of what? Solvent and solute, that can give solution. Simply mixing of solvent and solute together, that can make a solution. That particular solution is what? Liquid solution, because liquid is a solute and liquid also solvent. Both are mixing together, we can get liquid solutions, right? So these are three types, right? Three types will be there. So the first one will be completely miscible solutions. Completely miscible solutions, right? Completely miscible solutions means both solvent and solute mixed together, that can make a homogeneous mixture solution. Means that completely solute is dissolved in solvent, that can make a solution. Such solutions are called completely miscible solutions, right? For completely miscible solutions, examples will be, take small amount of hydrochloric acid, that will be added to water, right? Small amount of hydrochloric acid, that will be added to water, so that can give completely miscible solution. So therefore we may call as solution will be aqueous solution, that is aqueous solution of HCl aqueous solution, because water is solvent, right? Water is solvent. Such solutions are what? Aqueous solutions. This is about completely miscibility, right? Second one is about partial miscible solutions. Partial miscible solutions, only small extent will be dissolved, right? Only small extent will be dissolved. Such solutions are called partially miscible solutions, right? So what are the examples of partially miscible solutions, right? The examples for partially miscible solutions, whenever phenol added to water, only small portion of phenol is soluble, right? So that can make partially miscible solutions. Here we are going to discuss, this is the liquid solution only, but partially miscible solution, right? This is the liquid solution, partially miscible solutions, where we are going to discuss about the what? Critical solution temperature concepts. CEST concept we are going to discuss, right? So that is mentioned in our syllabus. That is particularly what? Partially miscible solutions. What is meant by CST? Critical solution temperature, right? Critical solution temperature. That is the minimum critical solution temperature, maximum critical solution temperature. All those things will be mentioned in our syllabus, right? Okay. Coming to the part of third category, partially miscible. Next one will be immiscible solutions. Immiscible solutions means, so both solvent and solute may not mix together in any extent, right? So as it is, that can make two layers, right? So that we may get, right? Example of immiscible liquids means HCl is combined with carbon tetrachloride. This is a one polar, right? Another one is non-polar. So that mixing of this polar and non-polar, that makes immiscible liquids. So this can make two-layer system. Two-layer system. Immiscible liquids means we can get two-layer system. So that two-layer system, one more example will be there. Water with N-hexane. N-hexane and water are immiscible liquids. So where we are going to discuss about distribution law. Where we are going to discuss about distribution law, right? So these all three will be mentioned in the syllabus, right? So first, completely miscible solutions means we can get various kind of solutions, like ideal solutions and non-ideal solutions we will get, right? So that we are going to discuss. Then solubility also mentioned, the solubility concept also will be discussed. In that we will get Henry's law and Raoult's law will get, so that is also will be discussed. That is applicable for what? Completely miscible solutions. Then coming to the part of partial miscible solutions means, so critical solution temperature we have to discuss. CST concept will be introduced. So that will be for particularly partially miscible solutions. What is meant by CST? So what are the phenol water system? How we are getting the concept from that we'll see. And some more will be there immiscible. Last will be mentioned distribution law in our syllabus. Therefore, we are going to discuss about the what? Distribution law also. These two are doesn't mix together, that can make two layer systems, right? One will be above layer, one will be below layer, based on the density. Whose density will be less, that can make occupy above layer. Density will be more, that can make below layer, right? So one is the water, other one is the organic substance. Therefore we may call as two layer system, that is organic layer and aqueous layer, right? This is the overall entire syllabus. That is in liquid solutions, which part we have been discussed? That is liquids in liquids only. Liquids in liquids. Other two also will be there. Solid in liquid and gas in liquid. That is the will be discussed in terms of solubility. What is the solubility of solid in liquid? What is the solubility of liquid gases in liquids? So that three we are going to discuss in detail. So before going to that, so we have to know some terminology, so that which will be related to that solutions, right? So whatever is the solution is there, how we have to say the concentration of the solution. For example, water is there. Water is a solvent, or that may be combined with some minerals, so that can act as solution, right? If it is a pure will be there, that is a solvent. If any components are mixed, like hardness of water means calcium and magnesium salts are present in the water, that can make hardness. So such minor components will be present in that water. Therefore water will be act as a solvent and minor components will be act as solute. So for that solution we are going to discuss. Then what is the concentration terms, right? The concentration terms will be denoted to the solutions, that is based on the solute, based on the amount of solute, how much amount of solute is present in the solution. Based on that we can get so various methods for expression of concentrations, right? Methods, next put heading methods for expression of concentrations, right? Methods for methods of expression concentration. Methods of expression concentration. Right. So there are various methods are there. What are those methods to express the concentration? This is based on amount of solute. This is based on amount of solute with respect to solvent. what kind of solvent is there, right? Then how much amount of solute will be present in that solvent that can make solution, right? So based on this, there are various methods are there to express that concentration. Just we are going to see. So the first one will be weight by weight percentage method, right? The second one will be weight by volume percentage method, right? Weight by volume percentage method. Then the third one will be volume by volume percentage method, volume by volume percentage method, right? So then the fourth one will be molarity, that will be denoted with M. The fifth one will be normality, that is the N. Sixth one will be molality, that is the M. Seventh one will be mole fraction, that is X. Then eighth one will be molality, molarity, normality, molality, mole fraction. Then eighth one will be ppm, parts per million. So then ninth one will be solubility, right? Even strength of the solution also will be there, so that will become under this only, right? These are the major part of methods to express the concentrations, right? That concentration will be based on what? How much amount of solute that will be present in the solution. That solution will be related to solvent, right? So actually this will be what? This will be how much amount of solute which will be present in the solution, right? So that solution will be related to what? Solvent, right? This is the conditions that can make the concentration terms, right? So we are going to discuss about all those things. Here we have to keep it in mind. These first three will be weight by weight percentage, weight by volume percentage will be applicable for 100, right? So the next four will be R3. So this next three will be applicable for 1000. This is 1000 ml or 1000 grams, right? Here 100 ml or 100 grams, right? So just we have to keep it in mind. Therefore from that we will get the definitions. So this is first three will be related to 100, that is either in ml or grams. The next three will be related to 1000 ml or 1000 grams, right? So somehow three will be quite different independently, right? So individual we have to make the definitions of all these three, right? So now we'll go with a little bit, right? Just for information only. So we'll do some questions also based on this, right? Weight by weight percentage. First one will be what? Weight by weight percentage, right? First one will be weight by weight percentage method. What is meant by weight percentage method? Means the first weight is belongs to solute, the below weight is belongs to solution. That we have to keep it in mind. So this will be belongs to what? Solute. This will be belongs to what? Solution, not solvent, solution. Therefore how can make a definition? Means amount of solute will be grams present in or dissolved in, present in 100 grams of solution. In total 100 grams of solution, how much amount of solute is present? So that can give percentage of weight by weight method, right? So simply weight by weight percentage we have to written as weight of solute in grams divided by weight of solute in grams divided by weight of solution divided by weight of solution, that is also in grams, multiplied with 100, that can give percentage, right? So this is the weight by weight percentage only, right? Weight by weight percentage, right? For example, right, 10 weight by weight percentage of 10 weight by weight percentage of NaOH. 10 weight by weight percentage of NaOH means what we have to say? NaOH solution, right? Solution means combined with water, right? So this we have to say how many grams NaOH? 10 weight means this first will be belongs to solute, that is 10 grams of NaOH. 10 grams of NaOH, which is combined with how many grams of solvent? The total solution will be, by combining of this total solution will be how much? 100 grams. What is the definition? The amount of solute which is present in 100 grams of solution. Total solution must be 100 grams. But how many grams of solute is there? 40 grams of solute is there. Therefore, what about the remaining? Right? Remaining 90 grams will be solvent. 90 grams will be solvent, that is the solvent will be water. 10 grams of NaOH, 90 grams of water, the total becomes 100 ml, so that is the 100 ml NaOH solution. 100 grams of NaOH solution, sorry. 100 grams means 10 grams plus 90 grams, overall 100 grams. Already we discussed that this weight by weight will be applicable for what? 100. Whether it is a weight means applicable for 100 grams, right? In this 100 grams solution, how much amount of solute is present? That will be expressed in terms of weight by weight only, right? Weight by weight. Similarly, weight by volume, volume by volume also similar to this only. Just we have to understand easily, right? So then see, similar to this, the next one will be, second one will be weight by volume percentage. Weight by volume percentage. So this first W already I told that this will be related to what? Solute. The V will be related to what? Solution. So similarly here, this first term will be related to solute, below term will be related to solution. Here also same, right? So therefore, how we will define means the amount of solute, right? Amount of solute. AMT means amount of solute. Amount of solute, that solute will be in what? Grams. Present in, right, or dissolved in 100 ml of solution, because that solution will be expressed in terms of volume only, right? Amount of solute is present in or dissolved in 100 ml of solution. So therefore, what was the formula we have to use? Weight by volume percentage is equals to weight of solute in grams divided by volume of solution multiplied with 100, right? As similar to that only, right? So this is the formula, right? So therefore here just will go with example or question directly, right? So what is meant by 15% 15 weight by volume percent, 15 weight by volume percentage sucrose solution. Sucrose solution or sugar solution, whatever it, right? So we may take this. So that means what is the 15 grams means this will be belongs to solute, that is a sucrose, right? So therefore 15 grams of sucrose, this 15 grams of sucrose which will be present in how much? 100 ml, right? 100 ml solution. So therefore how much amount we have to take the solvent, right? 15 grams will be, so that is 100 ml of solvent, water, right? So these both will be combined together, we can get 100 ml solution. Sir, by adding 15 grams to the 100 ml, little bit volume will be increased, right? So then how we have to prepare that solution means, so first we have to take a 100 ml standard flask, in that take some amount of water, around 30 ml or 40 ml. Then add 15 grams of sucrose, dissolve it, right? Then after that you have to make up to the mark with water, that becomes exact 100 ml. If you take direct 100 ml and adding 15 grams, little bit water quantity will be increases, right? So the volume will be increases. At that time we will get 100 plus volume, right? So how we'll get this exact means, first we have to take small amount, then dissolve this solute, and after that we have to make up to the 100, that is becomes total 100 ml solution, right? So therefore solvent volume is equals to solution volume in this case of weight by volume percentage, right? So then coming to the part of volume by volume, both are in volume only, similar to this weight by weight, right? So volume of solute is present in, right? The third category is volume by volume percentage, right? So directly I am giving definition, right? Volume by volume percentage is equals to volume of, right, amount of solute. This amount of solute will be present in what? ml only, right? Divided by volume of solution, this is also in ml, multiplied with 100, right? Both are in ml only, volume by volume, right? So therefore we'll go with one example, right? 5% of HCl solution, 5% of HCl solution. 5 means weight by weight, volume by volume, volume by volume percentage of HCl solution. So this first will be related to what? Solute volume. So therefore 5 ml we have to take, 5 ml of HCl. This is combined with how much? So therefore we will get total volume becomes what? 100 ml. By combined with 5 ml is combined with 95 ml of water, so that can gives total 100 ml HCl solution, right? 95 ml. So make it clearly understand that, right? Weight by weight, weight by volume, next volume by volume. These are very important, which we can utilize in further determination of concentrations in terms of molarity, normality, mole fraction, and all those things also, right? So this is the equation and examples, okay? This is the volume by volume percentage. This all will be applicable for what? 100 only. If it is weight, expressed in grams. If it is volume, expressed in ml, right? So coming to the part of next concentration term, that is the molarity, right? Right. The next one will be what? Fourth one will be molarity. Molarity will be denoted with m. So I told that already, these are belongs to what? 1000, right? 1000 ml or 1000 grams. Okay, 1000 ml is nothing but what? 1 liter. Remember that molarity will be related to 1 liter. After that, that will be converted into ml. That will be very easy only, right? In that 1 liter solution, how many number of moles of solute is present, right? So simple. The definition will be number of moles of solute. Number of moles of solute is present in 1 liter solution. So total how much solution is there? 1 liter is there. In 1 liter, how many number of moles of solute is there? That becomes molarity. That will be N by V. V in liters. V in liters. But number of moles N is equals to, we know that weight by gram molecular weight. Weight by W by GMW. Gram molecular weight. So both W also is present in grams, right? So this is also is present in grams. Therefore weight by gram molecular weight we have to take. Therefore molarity is equals to weight by gram molecular weight into 1 by V in liters, right? If this liters will be converted into ml, that becomes molarity, capital M will be, right? Capital M will be weight by gram molecular weight into 1000 divided by V in ml, right? So this is these all the three equations which are related to what? Molarity. So if it is in ml, we have to use this equation. If it is volume in liters, we have to use this equation. So then volume is in liters, but number of moles will be given. Therefore, we have to use this equation, right? Right. So here so many transformations are there, right? So what are those transformations that we will see, right? This is the important equations we have to remember. So because we are not getting direct equation, so by examiner will make confusions to get, right? Okay, here weight by volume, right? So here weight by volume will be considered as, right, weight by volume. That is multiplied with 100. So that becomes converted as what? M is equals to weight by volume percentage into 10 divided by gram molecular weight, right? So that means this 1000 will be considered as 100 into 10. That 100 will be multiplied to this. That becomes weight by volume percentage we will get, right? So even this I am going to change little bit, right? So for our convenience, so that will be multiplied with 100 by V in ml. This is multiplied with 10. 100 into 10 means 1000 only, right? So for this weight by volume percentage, the overall weight by volume percentage, right? Weight by volume into 100, that becomes weight by volume percentage. Weight by volume percentage into 100. Whenever weight by volume percentage is given, therefore the molarity will be considered as like this, right? So but in addition to this, density is known, right? But density is mass by volume. Density is equals to mass by volume, right? So mass means that is about weight by volume. Weight by volume, right? Density will be weight by volume. So therefore this will be considered as, right? So in case of weight by volume means what we have to write? Density, right? So density, weight by volume is there. So therefore where in case of volume we have to write weight by density, right? So from this equation, volume is equals to weight by density. Weight by density. So in place of volume we have to write weight by density. That is molarity is equals to weight by gram molecular weight is there, right? First one will be weight by gram molecular weight is there into 1000 divided by, in case of V what we have to write? W by D. W by D, right? In case of volume in ml, that is W by D means in case of V in this equation. In case of V I am going to write W by D, right? Now what I have to consider means this 100 will be multiplied with 10, right? Now this weight by weight into 100 I will get. This density will come numerator. Therefore molarity will be equals to weight by weight percentage into density into 10 divided by gram molecular weight. If weight by weight is given, this is the formula we have to utilize. If weight by volume is given, this is the formula we have to utilize, right? So this is the formula we have to utilize, right? So with the help of this, so I am going to calculate the concentration of water. Every day we are using water. Daily water తాగుతున్నాం, right? Mineral water అని, ఆ వాటర్ అని, ఈ వాటర్ అని, మున్సిపల్ వాటర్ అని. కానీ వాటర్ కాన్సన్ట్రేషన్ తెలియదు మనకి, right? What is the concentration of water? How we will get see, right? So concentration of water, right? Or else molarity of water is the question. Molarity of water is the question, right? So మరి వాటర్కి మనకి ఏం తెలుసు? వాటర్ యొక్క డెన్సిటీ తెలుసు. డెన్సిటీ ఆఫ్ వాటర్ ఈజ్ వాట్? 1.00 grams per ml, రైట్? నెక్స్ట్ మాలిక్యులర్ వెయిట్ ఆఫ్ వాటర్ తెలుసు. మాలిక్యులర్ వెయిట్ ఆఫ్ వాటర్ ఈజ్ హౌ మచ్, రైట్? దట్ ఈజ్ 18 తెలుసు, రైట్? పర్సంటేజ్ ఆఫ్ ప్యూరిటీ, రైట్, డ్రింక్ చేసే వాటర్ కాబట్టి పర్సంటేజ్ ఏమంటున్నా 100% అంటున్నా. రైట్, సో అవన్నీ తీసుకుపోయి ఈ పైన ఫార్ములా సబ్స్టిట్యూట్ చేయండి. m ఈజ్ ఈక్వల్స్ టు, right, the molarity is equals to weight by weight percentage means this percentage of purity, this will be weight by weight means percentage, that will be 100, right, multiplied with density is 1.00 multiplied with 10 divided by 18. Therefore this is the what, 1000 by 18, right, therefore 55.55 m. What is the water concentration? 55.55 m. Right, any liquids will be there, not only the water, with the help of density and percentage of purity, so we can get the concentration, that is with the help of this equation only. These are common equations, right, molarity. So but this is the equation, weight by weight percentage into density into 10 divided by molecular weight. If density is given, if there is no density, weight by volume, we have to get weight by volume percentage into 10 by gram molecular weight. So these are the two equations we have to utilize to get the concentration in terms of molarity. Right, so here also one dilution formula is there, right, so that is also we have to written. Right, dilution formula, continuation, dilution formula, right. So what is the dilution formula? m1v1 is equals to m2 v2, right, m1v1 is equals to m2 v2, where number of moles are same, number of moles same. If number of moles are same means n1 is equals to n2, right. So if we have to use m1 v1 by n1 is equals to m2 v2 by n2, where number of moles are not equal, right. So whenever we are going to discuss about the dilution process of redox reactions, for the redox reactions the number of moles not at all equal, so therefore we have to utilize this formula. Wherever the number of moles will be same, for example acid base reactions, number of moles will be same, so therefore we have to use this, like HCl versus NaOH, HCl versus NaOH, right. So then here what, redox reactions we have to use redox reactions. For redox reactions number of moles are unequal, therefore we have to use this formula, right. So coming to the part of, right, any solution is consisting 1 molar, 1m solution is there, that 1m solution we may called as what, molar solution. 1m solution is called as what, molar solution, right. 0.1m solution is there, 0.5 we have to take first, right, 0.5 molar is there, right. So 0.5 molar is there. What is meant by 0.5? 1m means molar solution. This terminology exam lo em istadu chudandi, మోలార్ సొల్యూషన్ టర్మినాలజీ ఇచ్చేస్తాడు, దానికి అప్పుడు ఏం తీసుకోవాలి మనం, కాన్సన్ట్రేషన్ 1m అని తీసుకోవాలి, రైట్. లేదా డెసిమోలార్ సొల్యూషన్ అంటాడు, సెమీ మోలార్ సొల్యూషన్, డెసిమోలార్ సొల్యూషన్, రైట్, సెమీ మోలార్ సొల్యూషన్. Semi-molar solution means what is the concentration? 0.5, right. Therefore decimolar solution means decimolar solution, that is 0.1 molar, right. Centimolar solution, that is centimolar solution means centimolar solution, that is 0.01m. Next 0.001m, that is what, millimolar solution, right. So this terminology we will get in the question, right. So whenever a decimolar solution will be undergo dilution, therefore what is the concentration of the resultant solution, like that we will get the questions, right. So 1 molar means molar solution, 0.5 means semimolar, 0.1 means deci, centi means 0.01, then milli means 0.001 molar, right. Whenever mixture solutions are there, right, for mixture solutions how we can get the concentration of resultant solution, right. So for mixture of solutions, right, for mixture solutions mixture of solutions, right? So what is the concentration we will get? Concentration for mixture of solutions. So the solution A will be consisting molarity is MAVA, right? So the solution B consisting MBVB, we have to use small a's, right? MAVA, this is MBVB. So when these two are mixed together, these two solutions are mixed together. So what about the resultant solution, right? Resultant solution, molarity is what, right? So that resultant solution molarity will be M is equals to, what we have to take, MAVA plus MBVB divided by VA plus VB, right? So this VA plus VB also we may call as V total also, right? This is the formula we have to utilize for the mixture of solutions. Whether acid mixture will be there, base mixture will be there. So therefore we have to use these conditions for mixture of solutions, right? This is about molarity. Various equations we have been discussed for the molarity. So all kind of equations will be applicable for the normality also, but instead of number of moles we have to use gram equivalents, right? So the same all equations we are going to written for normality also, right? So just we will move little bit fast with normality, because as we understand all those things, therefore we can get normality will be easily, right? Putting normality. Normality will be denoted with N, right? So these all are formulas only. So just we have to remember all those formulas, right? So which formula can be useful for solving of the problem? So where we have to use that formula. Right. When molarity is applicable for number of moles, normality will be applicable for what? Number of gram equivalents. Number of gram equivalents, right? So what about gram equivalents? That will be, we'll see after this, right? Right. What is the definition? Definition of normality means number of gram equivalents present in number of gram equivalents of solute present in 1 liter solution. 1 liter solution, right? Similarly here N also what? Gram equivalents, that is weight by gram equivalent weight. So previously we considered as what? Molecular weight. మొలారిటీ దగ్గర ఏం తీసుకున్నాం? వెయిట్ బై మాలిక్యులర్ వెయిట్ తీసుకున్నాం. ఇక్కడ ఏం తీసుకుంటున్నాం? ఈక్వివాలెంట్ వెయిట్ తీసుకుంటున్నాం, రైట్? సో ఎట్లా ఈక్వివాలెంట్ వెయిట్ తీసుకుంటున్నాం? ఫర్ ఎగ్జాంపుల్ క్లాస్లో ఒక 80 మంది ఉన్నారు, రైట్? ఇండివిజువల్గా ఒక్కొక్కరు వెయిట్ డిఫరెంట్, దట్ ఈజ్ మాలిక్యులర్ వెయిట్. మరి ఓవరాల్గా క్లాస్లో మొత్తం వెయిట్గా యావరేజ్గా ఒక పర్సన్ వెయిట్ ఎంత అని ఎట్లా చెప్తాం? సో దట్ బికమ్స్ గెటింగ్ ఈక్వివాలెంట్ వెయిట్, రైట్? సో ఈక్వివాలెంట్ వెయిట్ ఫర్ దట్ పర్సన్ మీన్స్ సో దట్ మాలిక్యులర్ వెయిట్ డివైడెడ్ విత్ n factor. What is the n factor? With respect to that we can get the equivalent weight, right? So that is weight by gram equivalent weight is the n. So therefore all the formulas what we wrote for molarity, so that all will be utilized for normality also. Normality is equals to n by v, but n is equals to weight by gram equivalent weight into 1 by v in liters. 1 by v in liters, right? Next equation, that n is equals to weight by gram equivalent weight, right? Gram equivalent weight, this is the gram, right? Gram equivalent weight into 1000 by v in ml, right? So these are the three common equations. Next equation will be normality will be expressed in terms of weight by volume percentage. Weight by volume percentage into 10 divided by gram equivalent weight, right? Gram equivalent weight, if weight by weight is given. So if weight by volume percentage is given, right? If weight by weight is given, normality is equals to weight by weight percentage into density will be added. So just now all those how the conversions will be there, we have been discussed, right? So divided by gram equivalent weight. What is this equivalent weight? We will discuss later, right? So then coming to the next formula, right? After these two, dilution formula will be there. Dilution formula is what? N1 V1 is equals to N2 V2. Only one formula, right? So here we use it to stay number of gram equivalent always same. Means similarly ఇందాక ఏమన్నాం n1 is equals to n2, ఇంకో కేసులో ఏమన్నాం n1 is not equals to n2. కానీ ఇక్కడ అట్లాంటి పాసిబిలిటీ లేదు, ఎందుకంటే number of equivalents is always same only, right? So whatever the number of equivalents will be there, that all are same and always n1 is equals to n2. Therefore we have to use one dilution formula. This is only, right? So this is the important thing for mixture of acid and base, right? For mixture of acid and base solutions, mixture of acid base solutions, right? So for acid, what we have to consider? For acid, normality will be Na, volume will be Va. For base normality will be Nb, volume will be Vb. Therefore, so what is the mixture of solution, right? So the resultant mixture of solution, that is depending on this. If NaVa is greater than NbVb, NaVa is greater than NbVb, whose concentration is more? Acid concentration is more. Therefore we can get the resultant concentration or solution will be hydrogen only. Therefore H plus concentration, acid means H plus concentration, so this is the H plus concentration or normality, resultant normality, that will be equals to NaVa minus NbVb divided by Va plus Vb. Hence the resultant solution is what? Acidic in nature, acidic solution, because acid concentration will be more. ఏం లేదండి, యాసిడ్ని బేస్ని మిక్స్ చేస్తున్నాం, ఈ రెండింటిని మిక్స్ చేసినప్పుడు సొల్యూషన్ వస్తుంది. ఆ వచ్చిన సొల్యూషన్ అనేది యాసిడ్ సొల్యూషనా బేసిక్ సొల్యూషనా, దేన్ని బేస్ చేసుకొని చెప్తున్నాం? యాసిడ్ కాన్సన్ట్రేషన్ ఎక్కువ ఉంది కాబట్టి వచ్చిన సొల్యూషన్ ఏంటి? యాసిడిక్ సొల్యూషన్. మరి యాసిడిక్ సొల్యూషన్ యొక్క కాన్సన్ట్రేషన్ ఏంటి? H ప్లస్. దీని నుంచి pH కూడా ఫైండ్ అవుట్ చేయొచ్చు, రైట్? దట్ ఈస్ వన్ కండిషన్. సో దెన్ కమింగ్ టు ద పార్ట్ ఆఫ్ సెకండ్ కండిషన్, రైట్? ఇఫ్ NaVa is less than NbVb. NbVb అంటే ఏంటి? బేస్, రైట్? బేస్ కాన్సన్ట్రేషన్ ఎక్కువ ఉంది. ఇప్పుడు బేస్ కాన్సన్ట్రేషన్ ఎక్కువ ఉంది కాబట్టి వచ్చేది ఏంటి? OH మైనస్ కాన్సన్ట్రేషన్ ఆర్ రిజల్టెంట్ సొల్యూషన్ నార్మాలిటీ ఈజ్ ఈక్వల్స్ టు ఏమని రాస్తాం? బేస్ ఎక్కువ కాబట్టి, రైట్? సో NbVb మైనస్ NaVa డివైడెడ్ బై Va ప్లస్ Vb. The resultant solution is what? Basic solution. Basic solution. Resultant solution ఏంటి? Basic solution, right? So మరి థర్డ్ కండిషన్ ఏంటి? థర్డ్ కండిషన్, రైట్? If NaVa is equals to NbVb, right? సో ఇప్పుడు రెండిటి కాన్సన్ట్రేషన్స్ సేమ్. What about the resultant concentration? Resultant concentration will be, means that is the resultant normality. So that will be 10 to the power of minus 7 only. Because NaVa minus NbVb, that becomes same only. These both are same. Therefore that concentration will be equals to 10 to the power of minus 7. Therefore whose concentration means pH is equals to 7. Therefore such solution is neutral solution. This is the kind of various kind of solutions we will get with the help of normalities, right? These all are definitions of normality, normality equations, then that will be applicable for dilution formula and mixture of acids and bases, right? So this we have to get important, because by mixing of acid with base, the resultant solution will be acidic in nature or basic in nature or neutral in nature, and also whose pH will be so getting how, right? Just copy it. All concepts are very important, right? So this was not mentioned, but whenever we are going to discuss about the concept, definitely normality, all those things, molarity, mole fraction, all those things we have to know, right? So PPM, particularly mole fraction, we have to utilize in Raoult's law and Henry's law, right? So at that time we have to know all those things. Before only we are discussing about all those things. After that we will discuss our main topic. Right. So similar to molarity. So one more we have to write here. So what about that means? Right. If 1 n will be there, that is called as what? Normal solution. Normal solution. 0.5 n will be there. That is the what? Semi-normal solution. Semi-normal solution. 0.1 n will be there. That is deci-normal solution, right? Normal means nothing but what? Normality, right? 0.01 normality is there. Centi-normal solution. 0.001 normality is there, right? Milli-normal solution. As similar to the molarity also, right? Right. So then here we have discussed that equivalent weight, right? Equivalent right. What is meant by equivalent weight? So just we'll go with a definition, right? So I have the substance, right? This substance either combined with 1.008 parts of hydrogen or 35.5 parts by hydrogen or 35.5 parts by chlorine or 8 parts by oxygen. This substance either it may combined with hydrogen or combined with chlorine or combined with oxygen by how many parts? This is the parts. 1.008 parts by hydrogen or 35.5 parts by chlorine or 8 parts by oxygen. Either this may be combine or displace, right? Combine or displace. Either displace anna kavali leda combine anna. Inni parts of hydrogen will be combined to this substance, or so this 1.008 parts removed by the hydrogen from the substance. That will be equals to what? This will be equals to what? Its equivalent weight. That will be equals to its equivalent weight, right? So that is the actual definition. So simply we will get the equivalent weight with the help of equation, that is whatever it molecular weight divided by n factor. This n factor is different for different substances. N factor is different for different substances, that is called equivalent weight, right? So just I will give some examples for this equivalent weight, so from that you will understand that. Right. What is meant by equivalent weight and n factor? N factor will be different for different substances, right? So just I am giving n factor for different substances. Right. So n factor for acids. N factor for acids. What we will get? Basicity. N factor for acids is what? Basicity. What is meant by basicity? Means number of replaceable hydrogens. Number of replaceable hydrogens, right? So then N factor for bases. N factor for bases, that is called what? Acidity. What is meant by acidity? That is how many number of replaceable OH groups. Number of replaceable OH groups will be, how many number will be there? That is called acidity. N factor will be acidity for bases, right? So then N factor for salts. Salts, right? So salts ఏం తీసుకుంటాం? Charge on either cation or anion. Charge on cation or anion. ఏదైనా ఒకటే తీసుకోవాలి, right? So charge on cation or anion, that will be equals to N factor, right? Next, ions, right? Charge on ion. If it is ion is there, how will get the equivalent weight? Means with the help of charge on ion, right? Last one, oxidizing agent or reducing agents, right? Oxidizing agent or reducing agent, right? Here number of electrons either lost or gained. Number of electrons either lost or gained, so that can give the N factor for various substances, right? So for example, here I am going to calculate, right? HCl is there. What is the equivalent weight of HCl? E of HCl will be, right, molecular weight of HCl divided by, right, how many H plus it will give? Molecular will be denoted with M only. M divided with how many replaceable H plus will be there? 1. Therefore M by 1, right? Next, H2SO4 is there. H2SO4 is there. Equivalent weight of H2SO4. Equivalent weight of H2SO4 is that molecular weight divided by 2, because 2 replaceable hydrogens will be there, right? Like H3PO4, if you may consider, H3PO4 means equivalent weight is equals to M by 3. 3 replaceable hydrogens are there. Here 2 replaceable, here 1 replaceable, here 3 replaceable hydrogens are there. So that's why this is the thing, right? So then coming to the part of bases, right? So space is not sufficient, we'll move like other also, right? So this is about what? Base, right? For base, equivalent of any base is equals to molecular weight divided by acidity. N factor is what? Acidity for base. So here also same definition or formula. For acids, E of acid is equals to molecular weight by basicity, right? So we'll see like examples. NaOH. NaOH is equivalent weight of NaOH is equals to what? Molecular weight divided by 1 only, because it can replace only 1. Calcium hydroxide, right? Equivalent weight of calcium hydroxide, that is equals to M by 2, right? Next, aluminium hydroxide, whose equivalent weight will be what? How many replaceable OH groups are there? 3. Therefore molecular weight by 3. This all will be helpful in electrochemistry also. That's why I am going in detail. Right here 27 by 3. That means what is the equivalent weight? 9. Here calcium hydroxide will be, calcium will be 40. 40 plus 2 oxygens means 32. 40 plus 32 means 72 plus 2. 74 by 2. 74 by 2. That becomes 36. Oh, sorry, 37. right? So this is the equivalent weight is 40 only. So with the help of this, any base is there whose equivalent weight will be calculated like this. Like any salt is there, ion is there, oxidizing and reducing agent is there. So therefore we are going to calculate the equivalent weight. With the help of equivalent weight, so we can get the concentration, that is the normality, right? So that is the n factor for various substances, right? N factor for various substances. So just I am going with salts and other three, right? So I will get that equivalent weight. Right. Now salts I may consider. E of salt is equals to molecular weight by charge on cation or charge on anion, right? So charge on cation or charge on anion. So what is the charge on cation? For example, right, salt we have to take KCl. KCl will give K plus and Cl minus, right? So therefore equivalent weight of KCl is equals to molecular weight by charge on cation is how much? That is the +1 only, right? So or else next, calcium chloride. Calcium chloride will give calcium +2 plus 2Cl minus, 2 negatives are there or 2 positives are there. Therefore equivalent weight of calcium chloride will be molecular weight by 2. That is for salts, right? If any ion is there, right? If any ion is there, ion means considered as, right, N3 minus, azide ion this is, right? N3 minus means equivalent weight of N3 minus is equals to molecular weight divided by charge on ion is only 1, right? Next, CO3 minus 2. E of CO3 minus 2 is equals to molecular weight divided by 2, because charge will be 2. Irrespective of the positive and negative, so whatever the charge will be there, that will be considered as n factor. -2 ఉంది కదా అని -2 తీసుకుండద్దు, రైట్? +2 ఉంటే +2 కాదు, ఓన్లీ నంబర్ irrespective of the sign, right? So this is about salts and ions. Like similarly oxidizing agent and reducing agents, number of electrons will be lost and gained, so that will be expressed in case of electrochemistry in detail, right? So then we are moving to the next, right, next one, that is the molality, right? After normality, the next one will be what? Expression of molality, right? Molality, this is denoted with what? Small m. This is applicable here, we have to remember 1000 grams of solvent, right? This is only expressing the concentration with respect to solvent, irrespective of the solution, right? So simple, how we are getting the definition means number of moles of solute, number of moles of solute which is dissolved in 1 kg of solvent. See here, solvent only, not solution. Just you have to identify this difference compared to molarity and normality. So therefore what we have to write? M small m is equals to number of moles by weight of solvent, right? Weight of solvent. So but n is equals to what? Weight by gram molecular weight, right? Weight by gram molecular weight. So therefore molality m is equals to weight by gram molecular weight into 1 by W of solvent in kg, right? So if we have to written m is equals to W by gram molecular weight into 1000 divided by W of solvent in grams, right? So this is the only molality, so that can give small m, right? So that can give the what? Solvent weight we have to consider, right? Solvent weight we have to consider, right? So then coming to the mole fraction, this is very important. That is denoted with x, Right, simple definition, just to go through it. X is equals to the ratio of directly I am giving equation. X is equals to the ratio of number of moles of particular component by total number of moles of component. Total number of moles of components. ఎన్ని కాంపోనెంట్స్ ఉంటే వాటి యొక్క నంబర్ ఆఫ్ మోల్స్ని కన్సిడర్ చేసుకోవాలి. దట్ ఈస్ ద మోల్ ఫ్రాక్షన్. దిస్ ఈస్ వెరీ ఇంపార్టెంట్. We are going to discuss even further topics with the help of mole fraction only. So that will be related with vapor pressure, all those things, right? So therefore here consider A is a solvent, B is a solute. A is a solvent, B is a solute. What about number of moles of A? That is Na. Number of moles of B? Nb. So therefore what is the mole fraction of solvent? XA is equals to how many number of moles of A is there? Na. By what about total number of moles? It is a binary solution. Binary solution, right? Therefore Na plus Nb, right? Similarly Xb is equals to what we have to write? Xb is equals to mole fraction of B, solute, that is number of moles will be B by total number of moles Na plus Nb, right? If we add some Xa plus Xb is equals to Na by Na plus Nb plus Nb by Na plus Nb, so that will be, we will get Na plus Nb by Na plus Nb. So the sum of all the mole fractions always equals to 1. So therefore for two component system Xa plus Xb is equals to 1. For three component system Xa plus Xb plus Xc is equals to 1. For four component system Xa plus Xb plus Xc plus Xd is equals to 1. Like that we will get the mole fraction, right? So this is the one of the concentration term. Okay. After this mole fraction, right, one more will be there. That is what? ppm, parts per million. Right, parts per million, that will be used for hardness of water, right? This molality and parts per million will be used for hardness of water, right? So the next one will be ppm. ppm will be parts per million. Means how many number of parts of solute is present in 1 million part of solution, right? Number of parts of solute present in 10 to the power of 6 parts of solution. What is meant by this 10 to the power of 6? That is million part of solution, right? So therefore we have to written as parts per million is equals to number of parts of solute by total number of parts of solution multiplied with 100. Total parts of solution, multiplied with 10 to the power of 6, that is the million, right? So this ppm will be used to express the hardness of water. Hardness of water concentration will be expressed in terms of ppm, and the relation between ppm will be equals to 1 ppm is equals to 1 mg per liter. 1 ppm is equals to 1 milligrams per liter, right? That is, some other also will be there, degree Clark and degree French, right? Degree French and degree Clark units also will be there to express the hardness of water. But here our aim will be what? Parts per million, right? ppm. After this, there is a solubility is there, right? What is meant by solubility? What is the solubility of solid in liquid, right? What is the solubility of gas in liquid? After that, what about liquid properties that are like Raoult's law, and what are the composition? So that solubility concept will be mentioned in our syllabus. So we'll go in detail with the solubility and whose properties in the next class. Okay, thank you.